let's go to Google Trends. And it's good to go to Google Trends anyway to know what's going on. So if you look at chat Hugging Face first, yeah, and then, and by the way, you see the latest story. I think it was probably one of these stories. Okay, so you see that that is our chat GPT. No, that is our Hugging Face, more or less going up. And then Hugging Face is facing something that competes with it, first of all, in popularity. So let's do. Usually, people talk about Open GPT rather than OpenAI. Well, it's not really Open GPT, it's Chat GPT. Okay, let's edit Chat GPT. Well, that's how it shot up. At the end of the year, it was up. And whatever looked like Hugging Face doesn't look like it anymore. It looks like dust. Sorry to say about this. So let us change it for OpenAI. And it's the same picture. So let's put things in perspective. Who is who? Let's do a little diagram. And please, I welcome your participation. Speak up anytime. So it shows me all the pictures, but let's get a new one. Well, actually, that was a nice picture. We were comparing Hugging Face and OpenAI. So let's look how do they compare, but let's add something very important. And that's something very important. Who is the audience? Audience for Hugging Face is programmers. Now, who is the audience for OpenAI? And I think you will not argue if I say that that's humanity. So I can't even type. Humanity. And if it is humanity, then of course it's very clear why it is so popular. Compare the, well, I don't have to do any analogies. Okay, so beyond that, beyond the fact that who is the audience here, we can say that Hugging Face is an interface for the programmers. So let me quickly show the Hugging Face as a site, because we really need to keep it in mind. So here is Hugging Face. Okay, and I'm logged in here. That's why you see my models, but it gives you all of the models that people decided that they will share with the world. 135 models, thousands. It grows about 10,000 models per week. Every time that we meet, it's about 10,000 more. That's what they get you. That's what they give you as a programmer. You can also go through all these models as what is the subject. And that will be a good thing to compare later on. You will see that the subject of ChatGPT is much more limited, but that is their strength. So you can talk about image classification, you can talk about document question and answer, all of that. That's Hugging Face, very popular, was very popular until you start comparing it to OpenAI. Now, that is the data sets here. The data sets is 21,000, and all of that is open. You don't really need an account, which is free anyway. So that is Hugging Face for you. But let's go back. Let's go back to our webinar run. And so OpenAI appeared and ChatGPT appeared. What do we do with it? Well, what we do there is, first of all, let's give its due to the fact that it's popular. Just this morning, my wife sends me 2 or 3 articles about ChatGPT from New York Times, and that's how they, in the morning, some reporters, they talk about, you see, what you can do and what you can get out of it. Let's get it away, because that's not for developers. It's somebody talks to ChatGPT. Okay, that's not why we're here. The reason we're here is because we want to use it. I'm sorry that I show you all of the back end, but the reason we're here is because we want to do something with those models. So last time you can find here, we went through their basic quick start. It's right here. So I will open it right here, and I will give it to you as well. I will also talk a little bit about what we do with that. So here in chat, I'm giving you that link. What that is an introduction. Eventually, it will be for the programmer. Eventually, in the sense of down below, it will start showing code. There you are. But it starts as a tutorial on what you can do. So what can you do? Well, in here, they allow you to play with it as well, right? You can say, write a tagline for an ice cream shop, and we serve up smiles with every scoop. Now, practically, what do we do with it? One practical way is just use it right here. Now, why do I show it again? Because later on, when we start fine-tuning the models, we will be repeating essentially the same task, but now for fine-tuning. So you can ask a question using their given interface. It will think for a while and say that a good name for a horse and lightning. That's how they will show how to use it. Later on, still in this tutorial introduction, they will show what you need to do in the code. The code can be one of the two. It can be Node.js or Python. In this tutorial, really, they give you about 10 or 20 languages that you can program in. Then they say, do this. Get a repository that we prepared for you, download that, or in my case, maybe clone it first so that you have your own copy, and then download. Then the very important thing about API. So that is how they know who you are. If I am right here reading this tutorial, then I'm either logged in or not logged in. If I am not logged in, then when I try to use it here, it will pop up, show a pop-up, and ask me to log in. So I'll have to create an account. Now, some people think that you have to get in line and wait for an invitation. That's a little confusing. Yes, you have to get in line for the next version, but the current version is already available. Whatever I'm doing, I just signed up, and you can do the same thing. Now it knows it's me. You see that picture. Now it says personal. It's just because it's for my personal use. If I were a company, it would probably say company, and then it would expect a team of people. But right now it's personal with my work email, and then it goes into all the things that you may need, and one of them is the key. So let's go there. Let's go for the key, and it will allow you to create your keys. That is where it becomes programmer. It is not just a reporter from New York Times. With all respect to reporters, they're usually not programmers, even though it's become a fashion to say that you need to be a coding whatever you do. But those reporters don't show examples of code. Instead, you're the programmer. You need to create a key. I have my key right here, and I have put it into the into my environment. So if I go to the command line like this, iTerm, here I'm on the command line. And if I show my environment, then somewhere in this environment, there will be a code. I don't quite want to show that to you. That's very famous mistake people make. Instead, I'll close the screen and assure you that I do have it there. So let's, and by the way, that was probably run as part of this previous tutorial. Now we can close that. Okay, that's what you would do when you start. And then it would lead you through the, what do you do with that as a programmer? And the real important thing is this. Let us say you suggest a name for a horse, but now you want to give it some of the other examples. So when you just say, give me a name of the horse, that's what's called one-shot or zero-shot training, because you didn't give it any preparation. This is called few-shot training, because here you gave it an example of how you would call a cat. Here are a few examples of how you would call a cat. That's an example how you would call a dog, Ruff the Protector, or One the Canine. And now you're saying, now that you know something about me, show me a good name for the horse. Then they talk about how to make it a little bit unpredictable by raising the temperature. And that's it. You can use it out of the box. Out of the box, you get 4 different models. You may have heard about them, A, B, C, D, Ada, Babbage, I think, but I'll show you what they are for. Now, today I'm going to show how to improve the model. You saw that you can tell the model, that's how I usually call my animals. Well, what if you have many more examples like that, right? What if you have, in the example that I will show you later, there will be 2 different sports, 2 groups of tweets about different sports, and the only 2 choices will be baseball and something else. Unfortunately, I don't know about sports. So I don't remember what sport it is, but you will surely recognize that. So today we're going to talk about, I don't want to give those examples. I see that, that's very nice, but I really want to give you 1,000 examples. And that would be very inconvenient to give 1,000 examples every time that I ask a question, because here it is, that's a preface to my question. Given that I call the cats and the dogs this way, given that, tell me how I should call the next animal. Now, if I have 1,000 examples, my questions would be very long. They also point out that if you do that, the questions will also cost you much more, because you are paying for the questions that you're asking and for the questions that it answers. So training, fine-tuning is about creating a model that already knows about you. Now, here you can see the link to the slides. And if you can't, then I'll give you the link to the slides. So let us do this. Go into the drive. That's the slide. So I'll give you the link to the slides. Get link. I'll give it to you here. I will also download these same slides to my computer. Here it is, it already opened, okay. It's not many slides, no worries, but let's go, it will keep us organized. So what we want to do is fine-tune the model and continue using it from the code. We are playing the developer. So first of all, what is fine-tuning? Fine-tuning is when you customize a model, and it's a pretty limited customization. Lots of things are hidden. That's my practical experience. So as you see, that is a webinar that is not polished in the sense that it is not promoting anything. I might stumble, something might not work. It's the story of my learning and what I discovered. And what I discovered is that, yes, there are reasons, but there are certain limitations. And that's what you need to know about so that you can imagine what you can use. But to give you a bit more high-level goal, ChatGPT is right now on an enterprise level in the sense that it's working for humanity. When we see New York Times reporters, well, that's because OpenAI somewhere has hundreds, thousands, and maybe even hundreds of thousands of servers. And they are answering questions for all of the humanity. Now you see what's the difference between Hugging Face, which is a programmer's lab, valued at $2 billion, and OpenAI, and that is a hot new company for the humanity, valued at $42 billion, judging by the investment by Microsoft. So that's the difference between the companies and their goals, programmers, humanity. But what's the benefit of fine-tuning? Well, you get a subscription, you calculate how much will it be for you if you're making a business out of that. And you can find lots of tutorials now. I invented the business and I sold it. So that I don't have to give you, you find it on YouTube. But in general, I think the recipe now is you take one of those four models and you fine-tune it, you teach it about sports, and then you can ask questions about sports. You teach it about medicine, and you can ask questions about medicine. And with Hugging Face, this kind of teaching would require more skills, but it will be more flexible. With the OpenAI, you will need less skills, but it will be more limited. That's on the high level. Now, on the specific level, you can then get better quality results out of your specifically fine-tuned model. You can also train on more examples. You don't have to give it a bunch of examples before you ask, because you already asked those questions. So savings on many level. And maybe it is faster. So that is very specific, but what I outlined is a very wide area, very wide path. And we remember that GPT-2 has today, it has one more disadvantage. It doesn't know anything about 2020, 2021, 2022, because it has been trained on the data. Well, maybe I'm wrong about the last 4 years, but it doesn't know about the last 2 years. So it has been trained on old news. Therefore, you can ask questions about, in general, what's going on. Just yesterday, I saw a battle of rap singers powered by ChatGPT, where you can assign it any kind of persons. Two people, I chose Socrates and Derrida, French philosopher, and how would they battle in rap? You can find it, but that's what you do practically. As a programmer, what you do is you take that same model, you improve it with your examples. For example, up until now, you did it with a few shot learning, but now you're doing with the fine tunes. It's an improvement on a few short examples. And you can enter quite a few examples. You can, in the example that I show, you can do 1,000, and therefore the results will be better. That is the plan of using ChatGPT for the developer. And the question really will be, is not how you do it that I will show, but how you invent the use cases. Where exactly you will put ChatGPT to use. So one of the examples that I mentioned was battle of rappers, but you can invent yours. That battle wasn't paid and it wasn't practical. Besides, my personal opinion, I may be not right about this, is that it learns from the humanity, which is on the average is not the best minds, because you take the best minds and average them with the worst minds or with the average minds. So I don't think it's gonna be a genius. A genius is special, but sometimes you don't need a genius. A receptionist in the bank doesn't have to be a genius, and that's what you are training. So once a model is fine-tuned, it's easier. At least practically, it's easier. There was an interesting piece of news by the Sam Altman, who is the CEO of the product of OpenAI, and his opinion was that it's a terrible product. And then there was some but. So maybe you can think of it this way, but the result is that you need to be able to train and offer this model to your consumers, and let's see where we get, right? So what you need to do is this. You'll need to prepare a specific training data, and I will show you how you prepare this training data. Then you will have to fine-tune a model, and then you will have to use it. That's pretty much it. Now, let's go and do one more picture. Okay. So exactly how do we do this? I think actually I can show you a resume picture. Exactly what does it mean when we're saying fine-tuning? Here's what we mean. Let's look at an example of some kind of neural network. This is Playground, created by Google, created by TensorFlow, which is the child of Google. And it shows neural network in principle. It shows that you can, let's add maybe a few more layers, and that's a neural network. Your inputs go here, and your inputs are tweets, let us say, and then you decide how much, let us say 2-word tweets. That sucks, I love you all, that's great. Let's say that, and let's say how much influence is the first word giving you, how much influence is the second word giving you, and from other points of view, that will decide if it says that's, maybe it's a continuation of a phrase. In other words, that will be more understood in the context. So we really need another word and maybe another word. That's basically how neural network works, except that it has not 4 neurons, but somewhere around 4 billion neurons. So that's hard to draw. But in any case, that's the model that you train. You can get some very simple data. That's where you choose which data. And in this case, it becomes a 4 neuron, 2 layers network that I'm asking to distinguish between blue and let's call it yellow. So I click here and I'm saying train yourself. So it's pretty fast. It trained itself. Here it says 56 epoch. Epoch is going there and back. It goes there, that's called direct propagation, when it calculates the situation as it is now. And here it evaluates it against the known inputs. These are the same inputs that we will give it. And it says, well, pretty good, but it can still be better. So it changes these outputs a little bit, verifies how much will change the inputs, and that's yet another epoch. That's epochs, and that's interpolations. That's the model training itself, except that you need many, many more. Now, I'm talking about fine-tuning. What is fine-tuning? Well, as you can see, the model tunes itself initially. It trains itself and it gets some coefficients. What are those coefficients? You can see them here. Yes, that weight is minus 0.15, and that weight is 57, and so on, 0.57, and so on. That's original training. Well, in fine-tuning, what you're doing is you are downloading the whole model that has been training itself for maybe 2 days on 4,000 neurons, and now you're adding one more layer here, maybe one more layer. And in this layer, you put your practical data. So now it trains itself with your practical data. And that's the fine-tuned model. That's basically how it works. So let's go back. We said this is the comparison between Hugging Face and OpenAI, but they are very similar in many ways. They are both about AI. They both have libraries, except that this OpenAI gives you fine-tuning and more limited, and this one also gives you fine-tuning. So let's put fine-tuning here. They're similar, and now we're investigating the OpenAI fine-tuning. So we said here that that was the last slide, except for the price. Here are the names of the models: Ada, Babbage, Curie, and Da Vinci. And it says that the models are way cheap, more expensive, and very expensive, because there is a what? I think 50% difference. We multiply that, we get O2. So that's a big difference in price. Now, price for what? Price per token. A token is a part of word. There is no direct formula, how many tokens per word, and that's a complicated algorithm. I wish they would price it just per words, but they feel they will do right by tokens. On those tokens, you have to trust them, that indeed they give you the correct number. But you can think of tokens and words are pretty similar. Really, words are a bit bigger things than tokens, and it's by 25%. In other words, let's say 100 words will probably be 125 tokens. That's the rule of thumb. So if that's the case, then you choose which model to run. And of course, all examples will be on Ada, because that's the fastest and the cheapest. Makes sense, okay? So from now on, you'll go to the lab. Okay? So let me go to the lab. But before I go to this lab, I'll show you that this old documentation, now let's close so that we're not distracted. This is webinar run. That has all the right links. And you can look at how Hugging Face does the fine-tuning. But today we're interested in how OpenAI does fine-tuning. So let's call it AI properly, and let's go to their documentation. Okay, we go back to their documentation, and we discovered that it's way not perfect. I think by now you will agree that it's making a lot of noise, marketing, but not for the tutorials. Don't be surprised. Okay, now in here you have all the guides, and this is the guides for fine-tuning. Now there is a fine-tunes and there is fine-tuning. So we'll go to fine-tuning, which will explain basically how that works. And it will even start to show you what you need to do. For example, right here, I need to verify that I have it installed. Okay, so I need to go to the command line and paste this. and see if it even works. If I already installed it on this computer, it will work out of the box saying, oh, here. And if it's new, then it's new. But as you can see, it created everything and everything worked. So that seems like, oh, that's a good path. And I already have set this up. That's an environmental variable that you set up in some kind of, as they say, bash RC, ZSRC, and so on, depending upon your computer. So that is easy, provided you have Python installed. That it's a bit more technical. And from then on, it becomes real code. So they talk about that the examples should come as JSON format. And it all seems very easy. It says, just give me a prompt, like my cat's name is that. And if I ask you for a good cat name, you should give me that. So your examples, and there are thousands of these examples in each file, should talk about that's the prompt and that's the desired completion. Now, to me, that wasn't clear and wasn't obvious, and they don't give an example. So it looks like it is a tutorial, but don't despair. I'll show you there's an example. It's just that I'm preparing you. Not everything is as easy as its popularity would lead you to think. Now, what is this format? Each line is JSON, but multiple lines gets a fancy name JSON-L. JSON-L document, because these are common. Many JSON documents, and your regular JSON reader will be confused. Tell it it's multiple JSON lines of JSON-L format. Then tell it that you also have an interesting tool, CLI preparation tool, that is installed as part of my install. It's already there. And then you are supposed to understand how to do it and do that. Now, I was confused. I'll be honest, I was confused. Then it talks about how you use this preparation tool. And then it says, oh, it's easy. It's just create a fine-tuned model, save it somewhere. And where is that saving goes? It goes back to OpenAI, because you're logged in, it knows you. So when you save it, well, you use it. But you would probably agree with me finally that that's not a complete manual. Where is the complete manual? So first of all, you go to fine tunes. And that is more or less complete manual, but it is really a manual in the form of technical documentation. It's not an example. The real example is found on the web after search, created by OpenAI as a repository on GitHub. So let us go back where I give you the link. That actually is the link, but we'll go and obtain it right here. There you go. Let's go. Now, what I've done is I've taken their own repository called OpenAI Cookbook and made a fork. Let's look at how popular is that. There's 1,000 or 1.6 thousand, 1,600 forks. That's not overwhelming. That's not your billions of users yet, because that's for the programmers. So I can make my own fork. That's my own copy of the same repository. That's called Elephant Scale OpenAI Codebook. And the advantage of doing that is that, first of all, it won't disappear. You will be able to sync it with the upstream repository, with the original OpenAI. If they remove it, you still have your copy. But in my case, it's because if I want to add anything, if I want to add comments to this, I can. Now it's my repository. I can check things back in. Now that is what we're going to run, or at least imagine that we're running. I will start running it just to show you how it runs. But at a certain point, I'll stop running it. just because it will take a long time. Because as I showed you on where was my playground, it had those neurons. So let's go back to the playground. I think I closed it. But as I showed you, you have those neurons and they're numbered in the billions. So your computer probably won't do it, and it will probably run on their servers. That's why at a certain point, or maybe it will try to do it, but at a certain point, our live experiment will stop. Now, if you were working at one of the large companies where I teach, there I will probably run the whole thing. But if you're here, you're probably able to do it yourself. Okay, with all the preference, I'm checking if anybody says anything, but everybody's silent. Here's what you do. You open a terminal, right? And you say Python. First, you might say Python minus version, and it says 310. Okay, one of the latest, that's good enough probably. Then you just say Python. Now I can enter my commands. Now look at this. That really is a Python notebooks. And if you're familiar with Python notebooks, you can maybe download this code as raw and upload it maybe to Google Colab where you can run Python notebooks. But then it's a bit too much magic because you don't see how it works. You don't understand how it works. So it works just as well if you run the same code by copy pasting and doing it individual. I think it makes more sense. That's how I usually teach. I'm saying, guys, don't rush. First of all, copy this line, understand what it does, and then continue doing this. It's not dull. So first of all, what you do is discover that it doesn't work. No module sklearn. And that means my environment is missing sklearn. Okay, no problem. So pip install sklearn, right? And there you are. And I'm glad that it did this to me because you will get the same thing. So Python is the most popular language today. And one of the reasons is just easy. So we did this. Now that should work. It didn't for some reason. Okay, but I'm not going to disappoint you. What I will do is I will log in to my other computer where I tested that and where that worked. So 1 second. And I just say SSH 172.18.0.1. Now that only works for me, doesn't work for you because that's an internal name of my server. If I got it right, if not, I have to get another IP. Doesn't answer. Let us try 17. And if that doesn't work, let's try 10, 0, 0, 53. And it asks me for the password. Okay, now this also has Python 3.7, but that is also good enough. So here I can say Python, and I can still paste the same, and it will import it. Now, again, that's real life. I'm glad it works this way because you can see exactly the problem that you will run into. All these labs are polished, and that's very nice. But real life will give you that kind of surprise. So now import pandas, which is to work with data frames, and mostly import OpenAI. Okay, now that I imported all the necessary packages, I'm getting the data. So I'm saying I will talk about baseball and hockey. And no data so far, just the classifications. Now comes the data. The data comes in a specific format from news groups. And I told it what I plan to do. So therefore, it will create a data frame, which will be called sports data set. And it may take a little time when it starts, but you see, I really prepared, at least on the SATA machine. So there you are. It already downloaded that and stored it in the cache. If that's the case, I can look at my data. Now, before I go explaining every step, I will tell you the plan. So we import the data, look at this data a little bit, verify that it's in the right format. And then we're going to look at how much data we get. When the result is about 1,000 total, all labeled. So it will be some examples that are baseball and some that are hockey. And then later on, I will be able to ask this model, which is trained on specific sports. And now you get to see how much data is required to really train it in a specific sport. Just two kinds of sport require 1,000 examples, but then you get pretty good precision. You get 97, 98% precision. Okay, so it talks about how you prepare this data, converting the format. That's real. Now, I don't think that you would be able to easily recreate what they so playfully call that's the tutorial on fine tuning from this real notebook. So that everything is works here. And that I tested, and I even came to the point where it says, okay, now we're training. Fine tuning. So in Z, I was fine tuning and it promised about 10 minutes. I think in my case, honestly, I didn't finish it because it was already doing more than 5 and still going. But their result is a pretty good precision. So what the results are here, that's the test. %98. Now, I don't remember where it said so, but it does work. So I can assure you, in other words, let's continue just a little bit to see how it works. All these links are for you. So if you want to repeat what I showed you, it will work. And so what you're doing is, okay, I got the data set that I'm going to train. So I will investigate this data set. Here it is. Show me the data, and it gives me who was talking to whom, what they were talking about. And that's very specific. You need to be, you need to know who the teams are. You need to know cities, you need to be a Toronto fan. Then it works, or you need to be a computer that's training to talk about this sports. And we are the second part. Then you will look at, so what was it classified as? That's the same line of input, but now it has a label. It has a real classification put in there by humans. And we verified that that was talking about baseball. Now, let's look. Is it really talking about baseball? Because it doesn't mention the word. To fan, it's very clear that you're talking, of course, about baseball and not hockey. Well, guys, I need your knowledge. Is it really talking baseball or is it really talking hockey? What do you say? Okay, that's a good question about neurons. So we'll go back a little bit later. But I hope it's talking about baseball because the label says baseball. After that, you do this, say continue. You look at this data. I'll just do that. And by the way, you can copy the whole thing. No, we need to select and copy. That C was inserted by me accidentally. I really meant that. I don't know what that C is, but yes, indeed, it's more than 1,000 total examples. Baseball 597, hockey 600. Okay, well, it's a lot of information. In the class, I would spend probably 4 hours going through all of that, so don't be surprised. Now, a question from Varshal is, what was this playground? So playground right here, and I will give you the link to that. That's the playground. And that's the link to that. Is this. How does neural network work? Well, that's how. You give it a little decider. You call it a neuron, but what that really is if you're familiar with the machine learning a little bit, then that neuron is a regular logistic regression. So it decides yes or no. That's all it does. It really outputs this yes or no in form of less than 1/2 or plus 1/2. But it's just a little decider. Now the neural network takes this one, which used to be a subject of machine learning course with logistic regression and linear regression, and combines them. So combines, here's one little logistic regression or neuron or decider, or you can think of voter. And here's another one, and so on, and you get 4 voters. The next step is that whatever they decide, expressed in numbers, goes to the next one. But that's a very small neural network. It shows these are inputs, these are outputs, and only one level of deciders. But it was shown early enough that that's not enough, not deep enough, no deep thinking here. So you need more. You need at least that. Because if you do this, then you can solve more complex problems. Not all linear problems, but also non-linear problems as well. Now, what happens between this? Let's say this is a neuron, and it gives outputs to 4 other neurons. So you can think of a group of voters who transmits the votes to the next level. What do all these voters do with this information? They see that voter number 1 voted 0.12, and voter number 2 voted minus 0.18. So what do I do with this? One first idea is simply add them up. But if I just add them up, those numbers, so I'll look at what's the next one from here to there. That was 0.41. Then all I get is some linear combination of previous opinions. I must be able to reject some opinions. I must be able to add them up, or maybe multiply them, or maybe transform them. And that is the last thing that I need here, and is determined by this called activation function. So if it is linear, then it cannot solve this problem at all, because that's not a linear problem. But if it is not linear, but really is very popular today, then it solves it pretty easy, as you can see. So that is the essence of neural networks, and you can explain it to a baby. And really, there are books, neural computing for babies, you can find it. But you need a couple more steps. You need to think about, that's a very simple architecture. Neurons and neurons, it's like electoral votes, and all these groups of people give their input here, right? But that's not efficient. So you really need a more efficient specialized architecture. And then you learn about special architectures called CNN and RNN. And then you find out that came a little mouse and killed it all, that Hugging Face. And now that's a different neural network. So that other neural network is what we're dealing with. The OpenAI is what we're dealing with deep inside, hidden, and you don't have to learn about this anymore, because that doesn't matter. So even though Playground explains how TensorFlow and neural net, TensorFlow is just one library to do it, but in general, it's neural networks, then you will have to go through all of the specialized architectures that were popular, still popular, come to the latest, which is even hard to understand, called transformer neural network. And that is the neural networks that is used by Hugging Face and developed by Hugging Face and probably by OpenAI, but they won't tell you much about what they're using. And even that you don't have to learn, because as you can see, they hide all of that. It's just like knowing what's under the hood, and you don't have to know what's under the hood. So thank you for asking the question, because obviously it wasn't clear, because it's a lot of knowledge and history that goes there. Okay, well, I more or less showed all that I wanted to show. I think that the next time we'll talk about maybe some use case. How do you build it? And how do you train it some more? But nobody asks much questions because probably it's a lot of information. And thank you for your thank you. And you need to absorb it. The links are here. The webinar runner here. You can go back. But I don't think you need to learn all of that, because they are all making it easy. So we'll continue investigating exactly how you do it. You'll read about neural networks and tutorials. And then later on, we'll meet again next week and just compare the notes, how far you got and how far we'll get next time. So everybody, thank you very much. I really enjoy that. And I'll talk to you next week. Thank you. Thank you, guys. Have a great weekend. I see that Marshall asked a question, but I hope you ask it here. And don't forget that you can always talk. All right, goodbye for now.